Hi everybody. So in this video I want to introduce the concepts of atomic weight, atomic number, and then we'll also talk about the Bohr model of the atom in the process. Actually, we're going to start with the Bohr model. So the Bohr model, B-O-H-R, this is named after Niels Bohr, who came up with this idea, this way of drawing an atom. And the way we'll draw it is we'll start out by drawing some protons. So protons are atomic particles that exist in the nucleus and they have a positive charge. So we'll just make a little legend over here. This white guy with a plus sign in the middle is a proton. And then we'll add some neutrons. So put those in red, one here, one there, let's say one there. And so this red fellow, that is our neutron. A neutron is an atomic particle that has no charge at all. So it's neutral in charge. So there is this thing called the atomic mass unit, and the atomic mass unit, usually just written as AMU, protons and neutrons have an atomic mass unit of 1. So when we talk about atomic mass, which is related to atomic weight, what we do is we add up all of the particles that exist in this part of the diagram that we've drawn so far. I'll just put some dots around it. This whole thing is the nucleus. Now what I've drawn here is the model for lithium, Li, or Lithium, the element lithium. So the element of lithium has this abbreviation Li. So for the atomic weight, the atomic mass, we would add up all of these particles. We have 6 of them, and so we'll write a superscript 6 at the top upper left of lithium. And because there are 3 protons, we can write the atomic number. The atomic number is simply the number of protons, and that is the number 3. So the atomic number is simply the number of protons, whereas the atomic weight is equal to neutrons plus protons. So we put the atomic number as a subscript 3, although notice that it is not really necessary. When we write lithium, a lot of times we're just going to write lithium and then put the superscript 6, and we'll skip the subscript. And the reason why is because the number of protons defines the element. If we write Li, then we have to have 3 protons. We have no choice. If there are a different number of protons, then it would be a different element. If we write Li, then it has to be 3. Since it has to be 3, it's kind of superfluous. So a lot of times, actually almost all the time, we leave it off unless we want to do some accounting where we're adding up protons or neutrons in a nuclear reaction. Now, in the Bohr model, we also want to be able to track the other major type of particle, which are electrons. And for the lithium atom, we'll draw 2 shells. There's an inner K shell. It's usually drawn in the Bohr model as a circle that goes around the nucleus. And then we can have another shell. We'll call it the L shell. It goes around the K shell like that. The K shell can hold 2 electrons, so I'll just draw an E with a minus sign. We'll put another one down here. And then the K shell is full with just 2 electrons. It can't hold any more electrons. So since there are 3 protons here, if we're going to have an atomically neutral lithium atom with no charge, we need a 3rd electron. That 3rd electron will have to go into the L shell. So we'll just draw another electron over here somewhere. Doesn't really matter. So for the lithium atom, the way we've drawn it here, 3 protons, 3 electrons, the positive and negatives balance out, and so there's no charge. Lithium doesn't necessarily exist in the neutral state. This electron might be kicked out and be involved in some other chemical reaction somewhere else. leaving lithium with a positive charge. So we could write lithium having a 1 plus charge, or we might just write lithium with a plus without the 1, just to say that it has 1 more proton than it has electrons. So it's positively charged. And we could still write that it has a value of 6 here for the total atomic weight. Now, I've left a little space here in the middle so I can draw another neutron. So lithium can come in at least 2 different flavors. There's lithium that has 3 neutrons, but lithium can also have 4 neutrons, the way I've drawn it here. And if we want to symbolize that, we can write lithium with a superscript of 7. Again, we could write a subscript 3, but we've written the letters Li for lithium, so we don't really need the 3. But we do need the superscript, because lithium can have either 3 neutrons in its nucleus, or it can have 4. And in nature, both of them exist. And that's probably a good place for us to end on. If you go into the periodic chart, you'll look at the atomic weight of lithium, and I believe you're going to find a number that's very close to 6.941. And this has units of grams per mole. And in another video, we're going to look at Avogadro's number and the meaning of mole. But for now, I just want to leave you with this concept. So why is it that the atomic weight that's listed in the periodic chart, so this is what's in the periodic chart. So that's the periodic chart, and that's the weight for lithium. Why is it not exactly 6 or exactly 7? We can only have, for any given atom, an atomic mass unit, AMU, that comes in whole numbers. So we have a whole number 6 or a whole number 7, and I'm sure all of you have already guessed the answer. What this number is telling us is that most lithium in nature is lithium 7, but there's a little bit of a lithium 6, enough lithium 6 that it brings down the natural weight of lithium to a little bit less. So if you gather up lithium, if you pick up some minerals that contain lithium and then purify that lithium extracted out of those minerals, so you just have pure elemental lithium extracted from nature, it's going to be a mix of these 2 things we call isotopes. So iso means that we have the same elements, but they're of different weights. So we have lithium with an atomic weight of 7 and an atomic weight of 6. And in the natural mixture, it's going to be mostly 7, but a little bit of 6. So the natural atomic weight is going to be a little bit less than 7.